All right. Hello, everyone. I am James Snell, and I am the head of research at NearForm, and I am a Node Core contributor, TSC member, and I am going to be talking. Hopefully, the sound is all right. I'm going to be talking about aligning Node.js with the web platform. So basically, what does this mean? Well, yeah, there's a question that's been asked for for a while now. We're talking a number of years. Should Node.js implement the same APIs as the browser? When I got involved with Node Core back in 2015, there was this constant refrain as I was getting started from other Node Core contributors that Node's not a browser. It shouldn't implement the same APIs. Node runs on the server. It's a different thing. Yes, it's JavaScript in both places, but just ignore that fact, and it's just different. It has a whole different set of requirements. So it's for all this time there's been this argument, this idea that these are two completely separate things, and they're really not. They are quite similar, and there is a significant area overlap. There we go. So there is this significant overlap. So we have this what I call this gulf of unsameness between these that is perceived. It doesn't actually exist. So if you're looking at Node, if you're thinking of browsers, you're saying these are completely different things. They're not related to one another. They shouldn't implement the same APIs. That is fundamentally the wrong way to think about it. Instead, what we have is an overlapping space here, where there's some things that are unique to browsers, some things that are unique to Node, but there is an area where they overlap. We're talking things like event loop scheduling. We're talking things like handling URLs or HTTP client requests. There are things that developers do in both environments, and it makes absolutely no sense for these to have completely separate APIs, a completely separate way of doing things. So what we've been doing here recently with Node is going through and actually looking at the web platform APIs, all of the APIs that exist in the browsers today, and seeing which ones make sense for Node to implement. And there's going to be a lot there. There's a ton of APIs available in the browsers that just don't make sense for a server-side Node environment. One that you can imagine are APIs for reading device sensors, battery levels, and all these kind of things. It's just not something that is needed in Node, or even DOM rendering. It's not necessarily something that we need in Node, but those exist in browsers. On the Node side, there's APIs there that belong there. Things like an HTTP server, right, or setting up a DNS server or something like this. Things that only should exist on that server side. They don't exist in browsers. So I don't think we're ever going to see a case where the two environments implement all the exact same stuff. But this area in between, all right, where they do share functionality, where developers have to do things in a consistent way, just makes life easier for the developer if they don't have to kind of paper over or polyfill or account for the differences in these different environments. The analogy I like to use is when all of the browsers did things differently, when you had IE6 and Safari and Firefox, and they weren't aligned on these APIs, right? And you had to write code that was specific to Internet Explorer or whatever, right? Yeah, we all remember the notices. This website works best in Internet Explorer. We don't want to get back to that kind of thinking. We don't want to prolong that kind of thinking. There are areas where these things go together. So we started this process a couple of years ago, and the first kind of browser API that we introduced into Node, not without its share of controversy, was the WhatWG URL object. Up until that time, the way that we did URL parsing in Node was that we had this URL.parse method. And a couple of years ago, we had a few reports that it was actually mishandling things like user IDs, passwords, that kind of thing. Yeah, in the URL. So if you had something like, a username and the password at whatever domain, depending on how the username and password were specified, URL parse would handle that incorrectly, and you get some wrong information. There's a few other bugs in the implementation as well. Well, rather than go through and fix those, because the implementation of URL parse is actually quite incredibly complex in order to get performance out of it, I took a step back and said, you know what? Let's actually do something completely different. Let's go ahead and start this alignment with the Node, with the browsers, and actually just implement the new URL object, the WhatWG URL object in Node itself. And now today it sits there side by side with URL parse. URL parse is not going anywhere. The old, we call it the legacy API. It's not going anywhere. It's going to be there probably forever. But now when you want to actually work with URLs, you have the same API as you have on the browsers, compatible to the specification. We run the same web platform tests that the browsers do to verify it. We work with the WhatWG URL standard when changes need to be made, and we're keeping this in to pace with what browsers are doing. In fact, I'm happy to say in some ways we are actually more spec compliant than some of the browsers with this URL. So it's there. It's been there for a number of years, and should be supported in every version, all the supported versions of Node today. Another example that we started a couple of years ago was the text encoder and text decoder. Now, really, this is just a way taking a typed array, encoding it, or to UTF-8 or any number of other text encodings, and back and forth between those. It takes the place where the same basic role as when we say buffer from, and you have some bit of text. Let's say this hello, and say buffer from, and we want to convert that from UTF-8. It serves the same basic role of that, but it uses that standard API that is defined by the WhatWG encoding standard and implemented in the browsers. So it's been there. That's been there for a couple of years now. Here recently, just as a matter of 2 weeks ago, we did land finally BTOA and A2B implementations in Node. So those will be coming in as part of Node 15 within as part of the buffer module. So it'll just require buffer BTOA to access it in Node 15, and then hopefully Node 16 and beyond. Those will be globals, just like they are in the browser. Now it's a minor thing, and in our documentation we actually say, they're here, but you probably shouldn't use them. They're old APIs that they've only been added to have this cross-platform compatibility. It's actually better if you still use the buffer APIs for doing base64 encoding when you are focused strictly on the Node environment. And just as a side note, Node also now understands URL safe base64. Now this is a browser standard. I just wanted to point this out. But we've always had base64 in there, but if you now use this base64 URL, you will get the URL safe encoding for for that data. So very useful. The text coders have been in there again for a number of years. It should be supported in all the versions of Node that are all the LTS versions actively out there. More recently, we started another effort, and this was last year, 2020, where we introduced event target to Node as well. Now, Node has always had event emitter. And has always been an event model. Like everything in Node is an event emitter for emitting these events, handling them, doing whatever you want with that. But this event target has always existed in the browsers as the way of doing events in that environment. And there's a lot of similarities. There are some very real differences between the models, but they basically do the same thing. They handle events, dispatch and handle events. And it really just didn't makes sense to keep avoiding implementing event target in Node, especially when we get to some of the later use cases, which I'll talk about in a minute. So, it was, let's just go ahead and do it. Implement event target, implement event. Yes, it duplicates event emitter, but that's okay. And so we have this. There's some differences from what's in the browser. There's no such thing as hierarchical event bubbling in Node. We don't have this hierarchical DOM model that we need to work with. So it's just not necessary to have that in Node, and very little. There's very little in Node that would lend itself to requiring that hierarchy. But we can create an event target. You can create an event object, dispatch it, handle it. You can create your own custom event objects, pass those around. It's the same API as in the browser, and again, we verify that using the web platform tests, the same tests that the browsers use to verify their compliance. So that's there. That's available now. And probably, I think it's only from Node 14 up. It may not have made it back to Node 12. So it may not quite be available for everyone yet, but it's there and it's coming. Now, one of the primary use cases of event target for us in Node is for the abort controller implementation. Now, anybody that's familiar with the Fetch API and browsers should be familiar with the abort controller. This is the means of just bailing out and aborting the HTTP request that Fetch issues. Within Node, we are going through and we've decided to use abort controller and abort signal as kind of the idiomatic standard way of canceling asynchronous operations. Pretty much across the board. And we've started a process of integrating abort controller and abort signal throughout many core APIs. Child process, when you exec a file, or fork and spawn a new node process, you can pass in an abort signal and use that API to cancel it. File system, like if you're reading a file, connecting to an HTTP server. Listening for net requests, right? Or when you're working with streams, a waitable timer, UDP datagram, throughout all these different places, you're starting to see abort signal be supported. Now, the abort controller or the abort signal is an instance of event target, and it is the first case where we have implemented event target as opposed to event emitter. And the reason for that is spec compliance, right? We don't want to just implement APIs that are like what you see in the browsers. We want to implement the same APIs in a standard way so that they work consistently across these different environments. And only where the semantics of the implementation have to differ is where we want to, or we're going to call out those differences very, very clearly, like the lack of hierarchical bubbling in event handling, right? If it just doesn't make sense in Node, then we won't implement it, and then and we'll very clearly call those things out. Now, just to give you an idea of how this works, we also have this notion, recently added notion of a waitable timer. So you can basically have a version of set timeout that returns a promise. In this particular example, we create the abort controller. I'm creating a race between two of these set timeouts. One is going to wait 1 second. The other is going to wait 2 seconds. The one that waits one signals an abort. And notice that in the seconds, we're passing the abort signal in. So when in this particular case, when the abort signal abort controller is triggered, right, the second timeout is going to bail out early with an error, until which we handle by just saying, hey, okay, this was aborted, right? So this pattern, whenever you see this signal option, right, that's kind of the idiomatic way that we are setting this up to where you can cancel these asynchronous operations throughout Node. Okay. Now that's support for this is varies. There's some of this in 14. There's some being added to 15. I expect a lot more to come in Node 16. It's going to take some time to get all these APIs supporting this. So just look for it and give us a bit of time. And one of the other classes that we have that implements event target is message channel. This is this is introduced as part of the worker threads support. So Node now has multiple threads. It's an API that's similar to workers in the browser, but not quite the same. But it allows one-to-one message passing back and forth with the across these threads. The message port is an event target. You create the message channel. This is the exact same API that you can use in the browser. And we use this for messaging back and forth. All right, so another example we have is broadcast channel, whereas and broadcast channel is a new API even for browsers. Not it's not well known. It's not out there too much, but it does exist there. And where the difference between message channel and broadcast channel is where message channel is one-to-one. Broadcast channel is one-to-many. So any broadcast channel object you create that points to, that references the same channel name, right, is going to receive a copy of that message. All right. So, here we're creating two, and it doesn't matter. These can be in different worker threads. So I could spin up, I could spin up 100 different worker threads, all of them having their own broadcast channel, do a single post message, and all of them will get that message. So it makes for a very flexible way of passing the data around. This is again the same API. It works the same way in Node as it does in the browser. Now, the one difference with browsers is that the broadcast channel namespace is based on the same origin, right? So if you have worker threads that all exist within the same origin space, those will receive the messages. Whereas in Node, there's no such thing as an origin. The namespace is process wide. So any bit of code in that Node process can create the broadcast channel, connect to the same to the same channel name, and receive that data. So there's again some slight semantic differences where they make sense, but the API is the same. Now, another one, and a much larger one that we added recently, this was last year as part of Node 15, is Node now implements the webcrypto API. Again, same API that exists in the browser. How we get to it is slightly different. All right, so in the browser, you would you have a crypto global, and you can just go crypto.subtle and generate key. That's how you would do it in the browser. In Node, you import webcrypto from the existing crypto module, and that webcrypto object maps to the same crypto object that you would have in the browser. Okay, so from there you have a subtle object you can request. You can get random values. All right, and from that point on, it's exact same API that what you have in the browsers. So here, what we're doing in this example, we're creating an AES encryption key. Important thing here is these are asynchronous operations. The key generation, the encryption, the decryption happens off the Node event loop. So these are non-blocking operations. There's some slight differences between the existing crypto module and Node in terms of identifiers or some of the behaviors. This was written to match what is required by the webcrypto spec and what runs in the browser. We are currently working on introducing the web platform tests for the browser into Node to verify the webcrypto implementation. Webcrypto is still considered experimental in Node, so there could be some changes, and we are going through and working through some bugs. But as that matures, what I expect in Node, sometime in the Node 16 timeframe, is that webcrypto will graduate to fully support it. All right, so just again carrying through now this code, like I said, with the exception of how we get a reference to the webcrypto, this webcrypto object, all the rest of this code should work exactly the same in the browser as it does in Node, back and forth, and be completely portable. All right, so there's some other things that we're working on, and this is a very experimental one. Within Node or within browsers, if you're familiar with fetch, or if you're familiar with some of the objects that implement readable stream, and file the file APIs, then you may be familiar with this blob object. A blob is essentially kind of an opaque data buffer. It is immutable once it's created. So unlike a typed array where you can get to all the data and you can manipulate the data, right? It's the typed array is not opaque. You can dig into any part of it. A blob is considered opaque and immutable. Once it's created, you can't change that data. There's no accessors for the individual bytes. It's just there. You do have ways of reading from it using this .text or .array buffer. There's ways of getting to that data, but the data itself is immutable. Blob is one of the ways with fetch that you can read the contents of the request you just made, or the response you made. There is a experimental implementation of blob now in Node. I think it's out in Node 15 right now. It currently only supports the static data. So all the data has to be available when the blob object is created. One of the things that we need to do next is to have it support a dynamic data source where the data is streaming in, such as from an HTTP response or from reading a file. That work will be coming within the next weeks to a couple weeks to a couple months, somewhere in there, depending on the how we can prioritize that time. Blob is one of I'd say blob, event target. These things are part of the effort to eventually get to a fetch implementation in Node. A lot of folks have asked us about fetch. They want to see it. We don't have I don't have an example for fetch yet. Why? Because implementing is quite a bit more complicated than it seems. There's a lot we have to figure out, and there's other stuff we need to have in Node before we can do a proper fetch implementation. What WG streams, finishing blob, getting a form data implementation. Right, we got to figure out what we're going to do around cores, HP caching, and HP state. All things we currently don't do in Node at all. Figure out a more seamless HP version discovery and interop between HP 1, 2, and 3. So we need to figure all those things out. So fetch is coming. We just have work to enable it. So if you're hoping for fetch in Node, be happy. It will be there hopefully this year. In the meantime, go look at Undici. So that was a quick, whirlwind summary of things that we're doing within Node to align it with the web platform. I don't want to do that quick. So any questions, feel free to reach out to me if you want more information. I'm happy to chat.